Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sheraz, and in today's lecture we are going to talk about the molecular energy level and the interaction between the electromagnetic radiations and the molecule. Basically we have started the portion of spectroscopy on our channel, and in the previous lecture we discussed about the introduction and some important concepts related to spectroscopy and spectrometry. So if you people have not watched that lecture is present at the end screen and the link is provided in the description section. So without delay, we are going to start today's lecture. As we know that the energy is possessed by each and every molecule, and an isolated molecule has three types of the energies associated with it. So first of all is the electronic energy. The electronic energy associated with a molecule is due to the motion of electron. As you people know the concepts of the molecular orbital theory, MOT, and according to that theory, the electrons are shared between different atoms, and that electrons are present in the molecular energy levels, and the electrons are always in a constant state of motion. So electrons are moving between the two nuclei, and that motion of electron leads to the electronic energy level of the molecule. The second type of energy associated with the molecule is the vibrational energy. This is due to the periodic displacement of bonded atoms from their mean positions. So if you talk about, we have a molecule like the carbon dioxide. So this is the central atom and these are the two bonded atoms, and these two bonded atoms are not at the state of rest, but they are continuously moving towards and away from the carbon atom, just like a spring. Oxygen atoms are moving here and there in this manner. So this is also displacing from its mean position. So if this is the mean position, the oxygen atoms are always moving towards and away from the mean position like the spring, and this motion leads to the vibrational energy. The third type of energy associated with the molecule is the rotational energy. So this type of energy is due to the motion of molecule about its center of gravity. What does it mean? If this point is the center of gravity for carbon dioxide, so this carbon dioxide can rotate about its center of gravity in this manner, and this rotation of molecule would lead to the rotational energy associated with the molecule. So these are the three types of energies, and these energies are divided into different energy levels. So we have drawn here some limited number of the energy levels in order to make the idea of the energy levels clear. So these two broad bands are the electronic energies as shown E0 and E1. So this is the ground electronic state, this is the excited electronic state. So every electronic state has a large number of vibrational states associated with it. So these V0 and V1, the thicker lines, are the vibrational energy levels. So these are the divisions of the vibration energies. So every electronic energy level has a large number of the vibrational energy levels associated with it. So this energy level E1 is also having many vibrational energy levels. Here I have drawn only one, but many other are also possible that I have not drawn in order to avoid the confusion. So we can say that this electronic energy level is having these two vibrational energy levels, and this vibrational energy level V0 is having three rotational energy levels. So this vibrational energy level is also having three. So the main or the large unit is the electronic energy level. The next smaller unit is the vibrational energy level, and the next smaller unit is the rotational energy level. So you can look here that the energy gap between electronic energy levels is very large, followed by the energy gap between the vibrational energy level, and then the least is the rotational energy level, or the gap between the rotational energy level. So based upon these three types of the energy levels, we can interpret that a molecule can has three types of the transitions. Its electron can go from the lower electronic energy level to the high electronic energy level, just shown by this larger one arrow. So this is showing the electronic transition. A molecule can undergo transition from the lower vibrational energy level to the higher vibrational energy level, and these two vibrational energy levels are associated with E naught. So a molecule can be having ground electronic state, but it can be in an excited vibrational energy state. So when a molecule is moving from V0 to V1, so it is undergoing a vibrational transition, and same is the case with the rotational transition. A molecule having in the ground state vibrational energy level can undergo rotational transition. That is shown by a very small arrow if you can look here. So this rotational energy level is from R0 to R1, and these both rotational energy levels are associated with the ground vibrational energy state and the ground electronic energy state. So we can interpret from these transitions that the energy required for the electronic transition is the highest, and followed by the energy required for the vibrational transition, and then the least is the energy required for the rotational transition. So a molecule can have a number of transitions whenever the radiations are irradiated on it, and or whenever it absorbs the radiation. It's not necessary that upon the absorption of radiation a molecule must go from E0 to E1, or you can say it's not necessary that a molecule must undergo the electronic transition. It may undergo, if the energy is not suitable for electronic transition, it may undergo vibrational transition, and even if the energy is not suitable for vibrational transition, it can undergo rotational transition. So three types of transitions are possible, and it depends upon the energy of the incoming radiation that which transition would take place. The next is the interaction between the EMR and molecule. As I have explained here that number of transitions are possible. So we are going to look how a particular type of transition takes place. So every energy level has discrete energy associated with it, and only radiation of energy E is equal to h nu, that is equal to delta E, is absorbed. It means that only those radiations are absorbed which are having the energy exactly matching with the delta. And what is delta E? Delta E is the energy difference between two energy levels. It can be the energy difference between two electronic energy levels. It can be the energy difference between two rotational energy levels, and even it can be the energy gap between two vibrational energy levels. So if a large number of radiations are coming, so it's not necessary that each and every type of the radiation would be absorbed. Only that radiation would be absorbed that's having energy exactly matching with any of the energy gap between rotational energy level, vibrational energy level, or the electronic energy level. If the energy of radiation does not exactly match with any of the energy gap, the radiation would be transmitted. It's not possible that half of the radiation is absorbed and half is left. A radiation is either absorbed fully or not at all. As I have mentioned here, a radiation is fully absorbed or not at all. So here I have given an example. These are the two electronic energy levels, E0 and E1. Electron is present in the E0 energy level, and the energy gap between these two energy levels is the delta E, that is E1 minus E0. That's equal to h nu. If the energy of the incoming radiation is exactly equal to the delta E or h nu, it would be absorbed. If its energy is greater than h nu, it's not possible that the energy equal to h nu is absorbed and remaining energy is left or it's transmitted. And even it's not possible that two radiations are absorbed combiningly to make the energy equal to the delta E. So if a radiation is having exactly matching energy, then only it would be absorbed, and whenever it would be absorbed, the electron would be shifted from the ground energy level to the excited electronic state, and we would say that an electronic transition has occurred. So this was all about the molecular energy levels and the interaction between EMR and molecule. If you have any question related to this video, you can post your question in the comment section. We would meet in the next video. Up till then, Allah Hafiz.